We're going to be learning about translations. So our goal, our learning target, is by the end of class to be able to develop a definition of translation, perform a translation in coordinate plane, describe a translation that maps the preimage onto the image as a function. So you want to summarize that, to write it down for yourself. By the end of class, you'll be able to, the main thing we're going to be doing is performing the translation. All sorts of ways, but that's the gist. We're doing translations. You need to know this because knowing what transformations create congruent relationships is crucial to being successful in geometry. You need to know it because transformations can create congruent relationships. And most of what this class is going to be about is all about congruent. Same size and shape. And then last, you know you can do this when you can identify the vector that a preimage translates along, correctly translate a figure in a coordinate plane, given a description, and accurately determine the function rule when the preimage is translated. So you can identify the vector, translate a figure, and determine the function rule. It's kind of the highlights of it. So we're going to start talking about a transformation. Transformation is a little bit more of the general term. It just means taking one figure and move it around to another figure. So here's an example. Here we've got two figures. I can transform this one by moving it and then turning it a little bit, and then it matches up. That's a transformation, or actually a series of transformations technically. So moving one shape onto another shape, that's a transformation. The preimage is the original figure before the transformation. That's the key word there, before the transformation. Just like pre-season is before the actual season. And then the image is that's the after the transformation. And you note it with a prime notation, which is like an apostrophe. So the preimage would just have like a capital letter for the point. The image would have the same capital letter, but with a prime, with an apostrophe on it. Then a rigid transformation. Rigid mainly just means that it doesn't change size or shape. Preserves size and shape. They're congruent. Also, that's sometimes called a rigid motion or isometry. There's a chance that you will never hear the word isometry again, but it means so. Rigid motion, rigid transformation, you'll probably hear those a couple times. Isometry, maybe, maybe not. So a translation, that's now we're getting a little bit more specific. It's a type of transformation. A translation moves all points in the same direction and the same distance. It's like a slide, not like playground slide, but like sliding a shape. You can slide your book across your desk. You can slide a pencil across your desk, that sort of slide. And our next word here is vector. You actually know what a vector is because you probably saw this movie.
Go by the name of vector.
Just like vector in the movie, direction and magnitude. So it's got direction and it's got magnitude. So it has a length and then a direction. We'll see how that's usually represented here. But it starts at the initial point. So a vector kind of looks like an arrow. It starts at the initial point, which would be here, and then it ends at the terminal point. The terminal point is the arrowhead. The arrow's at the terminal point. So when you do a translation along a vector, it preserves shape, side length, orientation, parallelism, corresponding angle measures, all that sort of stuff. So stuff that was parallel, still parallel. All the side lengths stay the same, the shape stays the same, angle measures stay the same. What changes is position. That's what a translation does. It just moves it from one spot to another. It's just a move along the vector. So how do you know when to do a translation? There's a couple different ways that they're going to show. One way to know when to do a translation is verbal description. It says move something 6 units to the left and 4 units up. Or it could say right and down or whatever. The mapping rule looks like this. You got parentheses, X, Y, arrow, tells you how it's going to move. And this particular one's X minus 6, Y plus 4. That's because this is telling you to move 6 units to the left. 6 units to the left, X is the variable that tells you left and right. X tells you left and right. So if we're going 6 left, the 6 is going to be with the X. And then since it's left, left is negative, right is positive. Same thing, 4 up. Y is the one that tells you to go up and down. So since it's up, it's plus 4. You can do the same thing as a vector in component form. is basically you take that number that's with the x, put it first. The number that would be with the y, put it second. Inside these pointed arrow-like parentheses. So all three of these mean the same thing. There's even a fourth one that you might see a couple of times. It's a capital T for translation, and then it just tells you how it's translating, -6,4. You'll see that one probably the least. You can see all the numbers are the same. Left means negative, up means positive, left and right goes with the x value, up and down goes with the y value. With translation, we'll say we know the vector AB. That would be the same thing as our mapping rule, saying xy goes to x plus a, y plus b. Or you could, if you want to, you could even add this. Translation AB means the same thing. All of that, what it really, really means is A moves left and right. Since it's with the x value, it moves left and right. It moves left if it's negative, and it moves right if it's positive. And then similarly, B moves it up and down. It moves up if it's positive and down if it's negative. That's pretty much everything about translations right there. So we're going to translate 3 units right, 5 units down. 3 units to the right. So to the right and left, that's going to go first with the x. And since it's to the right, it's going to be a positive. Our mapping rule goes first with the x, and then since it's going to the right, it's a positive. So we're going +3, +3. And then we're going to go 5 units down. So down goes with the y, and down would be negative. So that's our mapping rule. The vector component form, it's the same thing, just written differently. It's just written in these arrowhead-like parenthesis things. So keep the 3 and the -5. That's it. You don't need the x and y. It's the difference between those two. The notation would be kind of the same thing. 3 and -5. So all 3 of those are telling you to go right 3, down 5. Same thing. So we are going to graph our pre-image, A, B, and C. So A is at 1, -3. Put the point and label it A. B is at 6, -6, 4. So left 6, up 4. Put the point, label it B. And then C is 2, 1. And label it C. So it does say that's a triangle, so go ahead and draw that like a triangle. And now we're going to do the translation. We're going to move all 3 of those points. Each point, we're going to move it +3, -5. So right 3, down 5. So these are the pre-image. Now we're going to take them and go right 3, 1, 2, 3, and then down 5, just counting it out. 3, and down 1, 2, 3, 4, 5. And now that's the image. That's after the translation. And remember we said we label that with the same capital letter, but we put the little prime symbol on it. Same thing with B. 3 to the right, down 5. And then finish it up with C. 3 to the right, down 5. And then that's also a triangle, so go ahead and draw it out. And then looking at it, you should be able to tell that it looks like they are still the same shape, still congruent, because they are. So this one's a little bit different because it doesn't give you the vector on your paper necessarily. You actually have to graph this out first. The initial point's 2, 6. We're going to draw the initial point there. Now, when you start doing that, hopefully quickly you notice that this is counting by 2s, because this would be 2 right there, and that's 4, 6, and 8. So it's counting by 2s, which means, personally, I kind of like to draw in some of the 1s in between them, just as a reminder. So starting at 2, 6. So here's 2 up to 6. That's our initial point. And then the terminal point is at 8, 1. So you go out to 8 and up 1. There's your terminal point. So we get the vector with the arrow part of the vector over here at the terminal point. Now the thing that matters the most from that vector, though, is just how much does it move. So we can see it's going to the right and it's going down. We just got to count it out. You can see it's going right and down, just count it out. So don't forget to count basically by 2s. So 1, 2, 3, 4, 5. It's going right 6. 1, 2, 3, 4, 5, 6. Right is positive, so +6. And then it's going down, which is a negative, and you got to count it out. 1, 2, 3, 4, 5. Down 5. There's your vector. Now, if you convert that into a mapping rule, remember mapping rules look like X, Y, arrow. You really just fill in those same numbers. So +6, -5. All right, so now we know all of that. We're going to take these coordinates, 0, 0 for C. There's C. A is at -5, 2. Don't forget all the ones I didn't mark over here. So -5, 2. And then R, 1, 4. And it's a triangle, so you can draw it out. Now for the important part, we're going to move every single one of those points along our vector, 6, -5. So 6 to the right, down 5. So we'll start with C. Move it 6 to the right, and down 1, 2, 3, 4, 5. And then we label that C prime, because that's the after the move. With a little apostrophe on it. Same thing with A. 6 to the right. And down 5. And you label it A prime. And then R, 6 to the right, down 5. And then just like before, you can draw the triangle. It should be a congruent triangle, same size, same shape. It looks like it, because it is. So one more quick little demonstration with this. If we take this vector, it shouldn't be surprising or even that entertaining. But if you take this vector and put it at C, it should point perfectly to C prime. And if you take that vector and you put it at A, it's going to point perfectly to A prime. And if you take that vector and point it at R, it will point perfectly to R prime. That's what vectors do. So if it moved it the same, we could take that arrow and move it all around. All right, last thing. So if you take these coordinates and plot them, you get these two rectangles. And it's just asking for the mapping rule. So really just wants to know what's the translation. Now, the most important part of this is knowing which one you start with. So does it start with the primes or does it start with the regular ones? And the preimage is where it starts, which is always the regular letter, no primes. So we're starting at M, and that's going to translate to M prime. A is going to translate to A prime. H to H prime, and T to T prime. All of those move the exact same way. So you just got to count how they all moved. So it is going left and it's going up. Going left 2, 4, 5, 6, 7, and up 3. So the vector component form, left 7 means -7. Up 3 means +3. If you put that in mapping rule, same thing. but with your x's and y's, it'd be x minus 7 and y plus 3. And then the other notation, -7, 3.